Good morning, all of you. Today, we are going to see the module 2, wind energy. We are going to discussing about the fundamentals of wind energy and followed by wind turbine structure. Here, the fundamentals of wind energy. First, there will be always wind circulation across the globe that is caused by the temperature differences. And we know that the warm air rises near the equator that creates low pressure, while the cool air sinks near the poles that creates high pressure. This drives the air movement between the regions between equator and the poles. Also, there will be Coriolis force that deflects the winds due to earth rotation. Always, these winds will flow towards right in the northern hemisphere and towards left in the southern hemisphere that shapes the global wind patterns. Now, the local wind behavior depends strongly on geography and surface conditions, terrains, surface roughness, and various obstacles that influence wind speed, direction, and available wind power, etc. Also, the land and sea breezes occurs due to differential heating between the land and ocean waters. During the daytime, the land heats faster than the water, and hence the wind is going to blow from sea to the land. At the same time, during night times, the direction reverse as the land cools faster, and hence the wind is flow from land to sea in the night times. The wind energy generation depends on various factors such as air density, wind speed, and rotor swept area. Higher the air density increases the kinetic energy, and hence we'll get more turbine output that generates more power, more electricity. While higher temperature and humidity reduce the air density slightly, that decreases the power generation, energy generation from wind turbines. This is the structure of wind turbine we can see here. The wind turbines are mounted on generally at higher altitudes. This one here we can see. So this is the tower on which these blades are mounted, and an entire nacelle room is also mounted onto this tower. And here inside this nacelle room, all the equipment will be available, and the blades are connected here to the rotor hub. This is the rotor hub, and the three or four blades are connected to this rotor. Whenever the wind is hitting these blades, that will rotate, and hence the rotor hub, which is connected through a rotor shaft to the generator, that also gets rotated. And because of this rotation, here we can see the wind direction. Because of the wind, the blades are going to be rotated, and that is connected to a rotor. Here there will be a low speed shaft and a high speed shaft. The gearbox control low speed and high speed, and hence before the gearbox we are having low speed shaft, and after the gearbox it is high speed shaft. This high speed shaft directly connected to the generator, where in which we are having a fixed magnetic field, a static magnetic field. And in that static magnetic field, the rotor is connected to the coils that will rotate, and hence that produces the electricity. This electricity is captured through cables, and that is connected to the hub which is at the ground level. To face the wind direction, these wind turbines consist yaw kind of motion, and hence wherever the wind is coming towards that side, this will rotate. That motion is called as yaw motion. Here is the yaw drive we can see. An anemometer and wind vane set is to obtain the wind direction, and hence we can rotate this wind turbine